Hello, my name is Azin. I'm PhD student at Computer Science Department, and today I want to give you a presentation about drone fault detection based on RAS topics and machine learning classification approach. So let me start my presentation with introducing three robots that we have in the lab. So we have the TurtleBot 2, which can give us the runtime about 3 to 6 hours, and it is equipped with Kinect sensor. Also, we have a very expensive robot, about $80,000, SegwayBot robot, and it can give us the runtime about 4 to 6 hours, and it is equipped with 16 laser sensor and RGBD camera. Also, we have the Parrot Bebop 2, which can fly in 3D environments about 25 minutes, and it is equipped with sensor, GPS, and RGB camera. So if I want to give you motivation about this study, it's about using drone instead of men and people in dangerous environment. I'm sure that all of you heard about the tragedy that happened last year in Australia, a huge wild bushfire which threatened the lives of 1,000 people, and so there were so many firemen who put their life in danger to help other people and species of animals. So here the question is that how we can help them, how we can use our knowledge to help them. And the drone is the answer, which can fly in 3D environment. They can be used instead of firemen in dangerous environment to ease the fire, or maybe find the live people stuck in the fire and maybe help them to go to safe places. And this is the motivation of our study, but the drone itself needs to understand in the middle of the task. It should autonomously decide that is it safe for it to accomplish the task, or is it better to stop it and back to safe position. I mean, it should understand that is there any fault coming from the environment, or maybe the fault happening in the drone itself. It should understand it, and based on this, it should decide to what to do. So for this presentation, first I give you the motivation, and then the related work, and also the data collection, how we did pre-processing techniques, and then classification and evaluation, and then conclusion and future work. So here is the related work that we got the idea of our work from this paper. They use the drone, AR drone, to find out the fault occurring in their system, and they use also ROS, Robot Operating System. I'm going to give you introduction about what is ROS in next slides. And so they use machine learning classification approach to find out the fault and classify the fault that's happening in the system. But the difference between their work and ours is that they just use, the fault that's happening in the system. If you see here in the right picture, there is a fault happening in the blade of the drone, in the blade of the system. And here if you see that the blade also is faulty. So we want to, make the difference with this work by adding some other faults to the system. like maybe exceeding heat or wind that's happening in the environment and can affect the system and drone. So for data collection, we use Dr. Van der Boget lab, and there is 12 camera, if you can see in this picture, the right picture. There is 12 camera that, and here is the drone. And this camera can, record the drone position, velocity, angular position, angular velocity, and give us feedback about how it is moved. For example, we give the pass to the drone to hover and move forward and then land to the ground, and then with this camera we can detect the position and also velocity of the drone. And we did 10 trials with normal status and also abnormal status. And also we used a fan to make the wind for the system from the environment, and then we collect all the data. If you remember, I told you that this GPS, this drone is equipped with GPS, and we can also get the position from the GPS. But because of the, the lab itself, the GPS doesn't work in the lab, and that's why we should use the camera to detect the position and velocity of the system. So how we can send the message to the robot to move forward and then land or hover. It can be done by ROS, Robot Operating System. It's like it's like a message pass that you can send a command to the drone or your robot, and also you can read back from the robot or drone. So we use ROS to get data from the robot and also send the command to the robot to move forward or maybe turn left, turn right, and this is a communication system. If you want to know more about robot operating system, you can go to the website ros.org and find more about it. Then we did some pre-processing techniques on the system and our collected data, like data reduction. We eliminate the covariance matrix and also some of the noisy values, some of NaN values, and data cleaning. There are some missing values that we filled with the average values of neighbors. Also, we did normalization. We normalized all the data, the position, velocity. There were 12 features and there were 12 columns of data, but about, I think it's about 28,000 rows that we have, and we normalize all of them to be between 0 and 1. Then we did some measuring data, similarity, how they, the position, each trial is similar together, and also we visualize the data. We plus the X, Y, and Z position to see how they are meaningless or how they are meaning to us. And then we use classification approach, and I didn't spend time to tell you about what is machine learning and what is classification here is, because I'm sure that all of you know about it and how it works and how you can apply the machine learning classification on them. You can use actually we use 5 classification approach: SVM, k-nearest neighbor, and some of the other approaches. And then we evaluate our data with accuracy, precision, recall, and F1 score. And here you can see that what is accuracy is and what is precision and recall is, and what's the number that we got in our experiment. And for conclusion and future work, so we did data collection, and we try to find out how we can detect the fault in the system, and feature selection and pre-processing, and also the how we evaluate our data. For future work, we aim to use Hadoop and Spark to get online results, and we plan to submit our paper in a good conference, hopefully. And thank you for your attention. And if you are interested to work with robots, if you have any idea or you would like to learn more about ROS or robots, please email me or come and see me in the class. We can talk about it. Thank you.